So good morning. Today I would like to discuss with you how you can choose an appropriate scale for your graph plots and how you can easily represent the data points on the graph plot. Okay, so an example. Okay, we have this data set, if you can see it over here. Okay, we have, or we were asked to make a plot of m on the x-axis, okay, and 1 over h on the y-axis. Let us get going. We have this graph paper. The first thing that we need to do, we need to get the dimensions of the graph plot, meaning we need to see how many squares do we have on the x-axis and how many squares do we have on the y-axis. So if we start counting for how many squares we have on the x-axis, we have 1, 2, 3, 4, 5, 6, and 7. So we have 7 squares. This is 1, 2, 3, 4, 5, 6, 7. 7 squares on the x-axis. What about the y-axis? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have 11 squares on the y-axis and 7 squares on the x-axis. So how should we choose an appropriate scale to represent the data? Now, first let us have a look at the data that we are going to represent on the x-axis. We were asked that on the x-axis we should represent this column of m, and on the y-axis square root of 1 over h. Okay, so if we take a look at the data on the x-axis, it starts at 565 and goes all the way to 892. So the minimum value we are going to represent on the x-axis is 565, and the maximum that we are going to represent on the x-axis is 892. So the first question that we should ask, should we start our scale on the x-axis right from 0? Okay, and we plot over the whole of the x-axis, or should we start from something different than the 0? So how can we answer this question? Let us see. So we have the maximum 892. So we divide by 7. What is this value? Let us get our calculator. So we have 892 divide 7. We get 125. Okay, we get 100, something like 125. So we are going to round this number to 150. We're going to round it to something like 150, and we start counting from 0. So this is 0, this is 150, 300, 450, this is 600, 750, this is 900. Okay, now let us see how many squares we are going to use to represent data between between 565 and 900. So for on the x-axis, 565 is something like here. This is 500. It's 500. Okay, and this is 900. So if we use this scale, okay, on the x-axis, we are only going to use this part of the x-axis from here to here, only this part. How many squares are we going to use? 1, 2.5. So we are going to use, if we use this scale, starting right from 0, okay, and ending up in 900, okay, we are only going to use 2.5 squares to represent all the data. So this is going to be very small. This is not a good scale to choose. Our plot is going just to occupy this part of the x-axis. This part is going to be empty, and this part is also going to be empty. And this is actually not a good scale. So how can we properly choose an appropriate scale? So we decide that we are not going to start our x-axis from 0. Using this calculation or this type of calculation, we came to the conclusion that we shouldn't start from 0. Okay. If we don't have to start from 0, then we can actually start from something or from a value which is close to the minimum and end up in a value which is close to the maximum or higher to the maximum. So how should we calculate the proper scale? We do this. It is maximum minus the minimum divide number of squares. To apply this on the x-axis, it is going to be 892 minus 565, and we divide by 7. How much we are going to get? Let us use our calculator. So it is 892 minus 565 divide 7. We get something like 40. Sorry. We get 46.71. 46.71. 46.71. So we round it up to the next good scale. A good scale is typically multiples of 1, multiples of 2, multiples of 5, multiples of 10, multiples of 100, 200, multiples of 200, so on and so forth. Okay, multiples of 50s. Okay, so a good scale on the x-axis should be something like 50. Okay, from where we are going to start, if we take a look, okay, we are going to start our x-axis from 550. Okay, we are going to start the minimum from 550. So let us do our scale. So this is going to be 550, 600, 650, 700, 750, 800, 850, and this is 900. Okay, and we have on this axis m in the units of g. Okay, and what is the scale? It is 50. Okay, let us go and do the same on the y-axis. So if we have a look at the y-axis, okay, we can again check that the values on the y-axis are actually between 0.218 and a maximum of 0.313. So if we start from 0, okay, it is going to be 0 till 0.218 is going to be an empty part of the y-axis. Then we don't need to start from the y-axis. How we are going to get the scale for the y-axis, again, what we are going to do, always remember this, it is maximum minus the minimum and divide by the number of squares. So on the y-axis, the maximum is 0.313, the minimum is 0.218, and we divide by the number of squares. As we counted before, they are 11. Let us do the math. So it is 0.313 minus 0.218 divided by 11. Sorry, 0.313 minus 0.218 divide 11. So it is going to be 0.0086. Zero point zero zero eight six three. Okay, this is actually not a very good scale. So the next best thing that we can do, we are going to round it up. Are going to round it up to 0.01. So on the y-axis, we are going to round it up to 0.01. Which value should we start the y-axis? I think a good choice would be 0.21. Okay, and if we have an axis of 0.01, then the next one in the scale or on the y-axis is going to be 0.22, 0.23, 0.24, 0.25, 0.26, 0.27, 0.28, 0.29, 0.30, 0.31, 0.32. So this is our y scale. Okay, now let us remove this. Okay, it's going to be 1. The unit over here, it is going to be 1 over h and square root. So now let us start presenting our data or representing the data on the graph plot. Okay, for the first data point on the x-axis, it is 565. On the y-axis is 0.218. So let us start on the x-axis. So you have got two ways to do this. It will depend which way you like and which way it is more comfortable for you. So the first one, we're going to start counting. Okay, and what do I mean by counting? It is like this. So I know that the first data point is actually going to be around here. Okay, the first data point is going to be in this square, if you can see it. Okay, now let us zoom in a little bit. So I show you how I'm going to do it. Okay, we know that on the x-axis, the value is 565. On the y-axis, it is 0.218. 8. Okay, how we are going to represent the data on the x-axis? We know that on the x-axis, the big square or this square is of 50 units length. Okay, what about the small square? How much a small square on the x-axis is? It is 50 divide 10. It is 5 units. So we start counting. The first one is 555, 560, 565, 570, 575, 580, 585, 590, 595, 600. This is how we do the counting. Okay, so let us do the counting. So it is going to be 555, 560, 565. Okay, what about 0.218? Okay, on the y-axis, we know that this square, okay, the largest square, is of the value 0.01. So what is the value of a small square? We divide by 10. It is 0.001. Okay, 0.001. So let us start counting. This is 1. This is 0.211. Okay, here 0.211, 0.212, 0.213, 0.214, 0.215, 0.216, 0.217, 0.218, 0.219, and here is 0.22. So this is how you do the counting. For sure, you are not going to do that on the exam. You are going to just count them in your head. Okay, you are going to do the counting on the head, on the fly, if we can say. Okay, then it is going to be 1, 2, 3, 4, 5, 6, 7, 8. Here it is. So this is the first point. This is the first point. Okay. What if counting is a little bit difficult? It doesn't happen all the time that the scale is good enough that we can do the counting that easy. Is there another way other than counting? Actually, yes. What can we do, or what can we, how we can proceed? Let us see. So we have 565. How we can represent it on the x-axis? We see what is the closest scale mark that we going to use. So this closest scale mark next to the 565, it is 550. So what we are going to do, we are going to do a little bit of math. Say 565 minus 550, and we divide by 50. Okay, let us do the math. 565 minus 550. Okay, we divide by 50. We get 0.3. So what does it, how we can make use of this value? We are going to look at this one. Okay, the first value after the square, after the decimal point. So we get 3, meaning what? That we need to use 3 square or small squares. Then 1, 2, and 3. Okay, what about representation on the y-axis? We have 0.218. The closest to it is 0.21. So we have 0.218 0.218 minus 0.21. We divide by the scale on the y-axis, 0.01. Okay, this 0.218 minus 0.21, we divide by 0.01, 0.8. Also, how can we interpret this value? We are going to look at the first number after the decimal point. It says 8, meaning what? It is 8 small squares away from the 0.21. So let us count 1, 2, 3, 4, 5, 6, 7, 8. And here is our data, first data point. Surely in the exam you are going to do this. When you practice, you are going to do this type of calculation very quickly. Okay, it is not going not be as slow as we are doing it right now. Okay, let us go to the second data point. What is the second data point? It is 637. 637 and 0.237. So where is 637? We know it's going to be in this square over here, and 0.237 is going to be in this square, around this square, right? Okay, let us start doing a little bit of math. So it is 637 minus 600 divide 50. So 637 minus 600 divide 50. Now we get 0.74. What does it mean? Okay, we are going also again to look at the first number after the decimal point. It is 0.7 or 7, meaning it is 7 small squares after the 600 mark. What does the 4 means here? Okay, it means that it is closer, okay, to the square mark number 7 than it is to 8. And this is how we do it. So we have 1 mark, 2, 3, 4, 5, 6, and 7. And this is 8. What 0.74 means? It is not exactly 0.7 and it is not 0.8. It is closer to the 0.7 than it is to the 8th mark. So it is something like here. Okay. 5, 6, 7. It is something like here. It is not exactly on this mark. Okay. What about the 0.237? 0.237. What is the closest mark that we can use? It is 0.23. We divide 0.01. So let us do the math. We are going to get 7 squares. It is 0.237 minus 0.23, and we divide by 0.01, 0.7. It is 0.7, meaning what? It is 7 small squares. Then we start counting. This is 1, 2, 3, 4, 5, 6, 7. Okay, then the data point is going to be like this. Okay, see how this data point, it is a little bit away from the 7 mark. Why? Because we got 0.74. Now let us do another data point. So we have 675 and 0.248. Let us see, 675 and 0.248, meaning it is going to be around this square. Okay, it is going to be around this square. Now, 675. Again, we can do the counting, or we can use our simple calculation. Now, this one is quite simple. This is 100, 600, or 650. This is 650 mark. Okay, and this is the 700. Then the line in the middle is 675. So it is very simple, this one. Okay, what about 0.248? 0.248, it means that it is going to be 8 small squares away from the 0.24. So 5, 6, 7, 8. Now you can see we can do the representation much quicker. Okay, what about the other point? 723 and 0.262. 723 and 0.262. So we know it is going to be, this is 700 mark. This is a 700 mark. Yes. And 0.262. So we know it is going to be around this square. Okay. We have 723. Let us see how we can represent this 723. So it is 723. The closest mark is 700 minus 700, and we divide by 50. Okay, then we get 723 minus 700 divide 50. 0.46. 0.46. So what does it mean? We are going to go for 4 small squares. Okay, and it is going to be between 4 and 5 squares, but it is going to be closer to the line number 5 than line number 4. Okay, so it is 0.46. Let us do the counting. So we see 1, 2, 3, 4. This is 5. Okay, we have 0.46. This is what we got in our calculation. So it is going to be closer to 5 than, say, it's going to be somewhere over here. Okay, then what about 0.62? 262. Okay, about 262, it is calculating easy on the y-axis. So this is 261, this is 262. Then where we are going to put our mark, it is around here. Okay. What about 790.282? 790 is going to be around here. Okay. $790.282. Okay, what about 790? we can do the math, okay, which is 790 minus 750 divide 50. This gives us what? 40 over 50 is going to be 0.8, meaning what? It is 8 small squares. Okay, what about 0.282? It is easy. It is going to be 2 small squares away from the 0.28 mark. So this one is easy. 5, 6, 7, 8. And we go up 2 small squares, 1 and 2. So the mark is here. You can see now, if you find too difficult to do the counting, then we can do a calculation, or we can do a mix of both. Then 892 and 892 and 0.313. 892 is around here. 313, it is going to be around here, around this square. So it is 892 and 0.313. Okay, how we are going to represent 892? We do the math. 892 minus the closest to it is 850 minus 850. We divide by 50. Okay, it is going to be 42 divide 50. Let us do the math. It is a little bit away from the 8 mark. This 42 divide 50. We get 0.84. 0.84. So 8 small squares and a little bit away from the 8th mark. Okay, let us do the counting. 1, 2, 3, 4, 5, 6, 7, 8. But it is 84, so it is a little bit away over here. Now, what about 0.313? We count 3 up. 1, 2, 3. We count it. So the mark is over here. So the more the practice, the faster you are going to get on how to represent the data points. Okay, now we need to make a graph plot, the graph or the line. So how do we do a line? You need to use a transparent plastic ruler. Okay, a transparent plastic ruler. Okay, this is very important. So you have to put it and you try to move around your meter ruler such that, okay, that they pass through as many as possible as data points, as many as possible data points. Okay, this is the rule. You try your line to make sure that it passes close to as many as possible data points. So I'm trying it myself now. I think this is kind of a good data or a good straight line. It passes through or very close to as many as data points. Okay, so I hope this was clear for you, how we can choose our scale. Okay, if we should start right from 0 or not, and how to do the counting for the data points. Okay, let us do another example. I just recommend to you try to make as many as possible graph plots. Okay, try to do as many as possible. Okay, now we have this graph plot. Okay, We were told or were asked to make a straight line representation from R, 1 over R and L. We are representing on the x-axis 1 over R and L on the y-axis. So we are going to say that this is the x-axis and this is the y-axis. Again, let us take a look. If we can have a look at the data points, it starts at 18.5 and ends up in 45.5. Then we can see that there is no sense of starting the scale on the x-axis from 0. Okay, what we are going to do, we are going to start from something next to 0 or close to, close to the minimum data point. What is the minimum data point? It is 18.5. What is the scale that we can use? This is how we do it. Maximum minus the minimum, and we divide by the number of scale marks on the x-axis. We have 7. Let us do the math. Okay, it is 45.5 minus 18.5 and we divide by 7. What we are getting? 3.86. This is not a good scale. What is the next best scale that we can use and what is recommended? We use something like 5. So on the x-axis, we are going to start we have a scale of 1 square. It is 5 units. Okay. Let us do the marking on the x-axis. We are not starting from 0. We are starting from something different. Which good scale mark that we can choose to start from? I think 15. The next is 20, 25, 30, 35, 40, 45, and 50. So we see that we have 40, 15, and 50, which is going to take all the values on the x-axis. We have 5. Now, what about the x-axis? We again do the same or similar. We can see that we are starting from 23. We are rounding it up at 71. We don't have to start from 0. Then how we can choose the scale? It is maximum minus the minimum. Divide by the number of squares. So it is 71 minus 23 divided by 11. So 71 minus 23 and we divide by 11. We get 4.36. Again, we round this up to 5. Okay, from where should we start? I think a good choice is going to be starting from 20. So we have on the y-axis, it is 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, and 70, 75, Okay, let us label the axis. On the x-axis, the label is 1 over r times 10 to the power minus 3 ohms minus 1. On the y-axis, it is L centimeters. So on the y-axis, L centimeter. On the x-axis, it is 1 over r times 10 to the power minus 3 omega minus 1. Remember this value or this multiplication, okay, because it is very important when you are calculating the intercept and you are calculating the gradient. Okay, now let us start making the graph plot. Let me make a copy of these data points. Let me clear it a little bit. Okay, and let us start making how represent our data. First, remember on the x-axis, our every square is 5 units. Again, on the y-axis, every large square is 5 units, meaning that each small square here it is 0.5, and here it is again 0.5. Okay. Now we would like to present or represent 45.5 and 71. Notice for that we have to start from the top. Okay. Sometimes it might be useful if you make a copy of your scale on the top line over here. Meaning what? I can just with my pencil write 20, 25, 30, 35, 40, 45. Sorry, started from 15. Sorry. 15, 20, 25, 30, 35, 40, 45, and 50. This will help you if you are making a plot from above or representing the data points that are coming at the top of the graph paper. Okay, so what do we have? 45.5 and 71. So where is 45.5? We know that this is 45. 45.5 is this line. Okay, what about 71? We have here 70. This is 45.5. This is 70.5, and this is 71. So the data point is over here. Okay. Again, we have 37 and 57.5. So where is 37? Sorry, 57.5. 57.5, it is going to be around here. So we are expected to be around here. So this is 35. Okay. So 35. This is 35.5. 35. 35.5. 36. 36.5. 37. Okay. And we have 57.5. So this is 55, and we would like to represent 57.5. Okay. So this is 55, 55.5, 55, 56, 50. Sorry. Yes. 55.5, 56, 56.5, 57, 57.5. Okay, so our data is going to be around here. This is our mark. Okay, the third data point. It is 30.3 and 45. 30.3 and 45. So where it is 30.3 and 45, it is going to be around this square. So what is 30.3? This is 30. Okay, let us do the math and see how many squares. We can do the counting for sure, but let us see how we can do it with the counting. So we have 30.3 minus 30, and we divide by 5. 30.3 minus 30 divide 5. Yes, it is 0.06. 0.06. Okay, it is smaller than one square. Smaller than one small square. So it is something like here. Okay, something like here. And this is the 45 mark. So it is this data point. Okay. What about the other one? So it is 25.6 and 36.5. 25.6 and 36.5. So it is around here. This is square. Okay. This is 25. Okay. And this is 35. So let us start counting. We have 25.6 minus 25 divide 5. We are going to get 3 squares, I think. 25.6 minus 25, and we have divided by 5.12. Okay, 0.12. So it is one small square and a little bit further away. Okay, so it is 0.1, and over here. What about 36.5? Should we do the math? Yeah, okay, let us try with the math. It is 36.5 minus the closest to it is 35, and we divide by 5. Okay, we got 1.5 divide 5. 3 small squares. 36.5 minus 35 divide 5.3. So it is small squares on the y-axis. So it is 1, 2, and 3. 21.3 and 27.5. 21.3, 21.3, and 27.5. So 21 is going to be around here. Okay, 21.3 minus 20 divide 5. 21.3 minus 20 divide 5. This point 26. So it is between two squares and 6 squares. Okay, 1, 2, and it is a little bit over here. What about the 27.5? This is easy. This is 25, this is 30, then halfway is 27.5. So this is our data point. Okay, let us go for the final data point, 18.5 and 23. It is 18.5 and 23. So it is going to be around this square, this one. Okay, so where is 18.5? This is 17.5. This is 18. This is the 18.5 mark. What about the 23? This is 22.5. So this is going to be 23. Okay, so we are good with all our data points. Now let us draw the line. We can now remove this scale markings. We don't need them anymore. As we said, we are going to use a transparent plastic ruler. Okay, we try to do what? We try to make sure that the line we use or we draw passes through as many as possible data points. Do not try to force it. Okay, just make sure that you get the best data or the best line passing through as many as possible as data points. You might see that some data points are not exactly on the line. This is fine. They just need to be very close enough. If they are far away, then most probably I have done something wrong, and you can check if a data point is very far away from the line. Otherwise, this should be fine. Okay. So this is how we do our graph and how we represent our data on a graph. This is very important and essential. If you are going for the IG, if you are going for the AS level, if you are doing it for the A level, you will always get some data points that you need to represent, and this is how you can do that. Okay. Now let us practice and see how we can get the gradient from this graph plot. So to get a gradient, we need to draw a right angle triangle. Okay, let us see how we can do right angle triangle. We need to get a large enough right angle triangle. We cannot use this kind of right angle triangle. We cannot do this one. This is very small, if you can see it. Okay, this is not allowed. It's not a good choice. A good choice would be something like this. Something like this. Okay, so the gradient sorry, is change in y divided by change in x. So how we can calculate the change in x? Let us get the data points. So what is the data point over here? It is 45, okay, and 30. What is the data point over here? Okay, it is 20 and 22.5 and 30. Okay, so what is the change in delta x? Is 45 minus 22.5. What about the y-axis? So this point is 30. Are we 30? Yeah, no, 45. And on the y-axis, it is 70. It is 70.5. So what is the change in y-axis? Delta y is equal to 70.5 minus 30. This is going to be our gradient. Gradient is equal delta y divided delta x is equal 75.5 minus 30 divide 45 minus 22.5. 45 minus 22.5. So let us do the math. So it is 75.5 minus 30. We divide by 45 minus 22.5. It is going to be 2.02. 2.02. So this is the gradient. Gradient 2.02. What is the unit for the gradient? It is the unit of y-axis divided by the unit of the x-axis. So it is going to be centimeter divide 1 over r okay, and times 10 to the power minus 3. Okay, this is going to round up to 2.02 times 10 to the 3 centimeter ohms. Okay, so what about the intercept? So as we all know, an intercept, the intercept okay, the intercept is the reading on the y-axis if and only if the x-axis starts from 0. So we cannot always read or take a reading of the intercept as intercept with the y-axis if the x-axis doesn't start from 0. For our case, does the x-axis start from 0? No. So we cannot take an intercept with the y-axis as the intercept. So what should we do? This is how we do it. Mark any point on the scale, on the graph. Okay, let us take, for example, this data point. We take this data point. Okay, what is the x-axis for this data point? It is 25 over here. This is 27.5. This is 28. Okay, what is the y reading for it? It is 40. So let us remember this data point. It is a point exactly on the graph plot, on the graph, sorry. So 28 and 40. 28 and 40. This is the x and this is the y. Now write an equation like this: y is equal mx plus c. This is an equation of a straight line. Okay, this is an equation of a straight line. This is the y-axis, this is the x-axis. M is the gradient and c is the intercept. Now write the equation for the intercept. So c is equal y minus mx. Do we have a value for y? Yes, it is a point on the x on the line. It is 40, right? Minus, what is the gradient? We know the gradient. It is 2.02 times 10 to the 3. What is x? It is 28. But remember, 28 times 10 to the power minus 3. I should have been careful over here when writing this. 28 times 10 to the power minus 3. Okay? Now this is going to go away. This is going to go away. So 40 minus 2.02 times 28. Let us do the math. 40 minus 2.02 times 28. Okay, minus 16.56 equal minus 16.56. So the intercept is minus 16.56, minus 16.56. Okay. Yes, I think we are okay. We are okay. Good. So we get minus 16.56. So the intercept is minus 16.56. What are the units for the intercept? The unit for the intercept are the unit of the y-axis. So it is centimeters. Okay. Make sure that you practice as much as possible with different data sets, with different graph plots. Okay. And as you practice more and more, the graph plotting part is going to be straightforward and easy. I hope this was useful for you and see you next time. Cheers.